Welcome back to another Algebra 1 installment. This is going to be Chapter 3, Practice Test Corrections. First thing you'll notice is that this is number 1. Number 2 is actually y equals negative 2. Alright, determine whether the relation is a function. If the relation is a function, determine whether the function is linear or nonlinear. So, let's look and see if every input has its own unique output. Yep. Yeah. Oh, look at that. 4 has a negative 2. 4 has a 2. Oh, look at this. 8 has a negative 4. This is not a function. Not a function. Alright. Y equals negative 2. What I'm going to do for this one is make my little table. And I know that y is negative 2 no matter what x is. So negative 1, 0, 2, 5. And if we graph that, it looks like this: negative 1, negative 2, 0, negative 2, 2, negative 2, 5, negative 2. So I have this line right here. So the first thing we want to determine is it a function? The easiest way for me to determine if it's a function, if it's past the vertical line test. Is there any point where a vertical line passes through 2 points? No, there's no point where it passes through 2 points. So yes, this is a function, and then it is also linear. Excellent. Let's look at this one. Negative 4x plus 3y equals 1. Is that a function, first of all? Yeah, as a matter of fact, it's a function. And is it linear? Well, let's look over here. If I go to my Desmos calculator, I put in negative 4x plus 3y equals negative 1. Plug it in and look at that. So if I do my vertical line test and I run a vertical line across here, it doesn't hit anything. So it is a function. And yes, as a matter of fact, it is linear. So it is a function. It is a function, and it is linear. All right, let's go to this one. We have y equals negative 2 plus 3x squared. Well, I can tell you right there that it's not linear because it has a 2. This one I could tell is linear because I have both my exponents are 1. This one I have an exponent of 2, so it's nonlinear. Now, is this a function or is it not a function? Well, let's check. Negative 2 plus 3x squared. I'll go into my Desmos calculator. I'll put negative 2 plus 3x squared. I get that parabola. If I were to do my vertical line test, I see that there's no place where it passes through 2. So, as a matter of fact, it is a function. So I have a function that's nonlinear. All right, carry on. Find the domain and range of the function represented by the graph. Determine whether the domain is discrete or continuous. So if I look at this, I see a continuous. It's not a series of points. Because it's not a series of points, it's continuous. My domain, which is my x values. So this is my x and this is my y. So my x values, if this were to go on, this goes on forever and ever. Goes on forever and ever here. So x, my domain, is infinite. All real numbers. My domain is all real numbers. That's my domain. Now my range is different. My range, I have no values that are greater than 2. I have no values that are greater than 2. So y is less than or equal to 2. That's my range. It is right here. It is all these numbers. So there's none of these numbers. So it's less than or equal to 2. All right, let's look at this one. So I have 1, 2, 3, 4. I have 5 points here. And they're separate points, so it is not continuous. These are, in fact, discrete points. And I'm just going to go ahead and list these. So right here for this point, I have negative 1, 2, 3. So I have negative 3, 2. Negative 3, 2. For this point, I have negative 1, 0. Negative 1, 0. For this point, I have 0, 0, 3. For this point, I have 1, 2. And for this point, I have 1, 2, 3, 0. That point, I have 3, 0. So what's my domain? Well, my domain is negative 3, negative 1, 0, 1, 3. There's my domain. Negative 3, negative 1, 0, 1, and 3. My range is all my y values. So my range is 2, 0, 3, 2, and 0. 2, 0, 3, 2, 0. I don't need the second 0 because it's 0 is already written in there once. Alright, moving on. Evaluate the functions below for the output when x equals negative 1, 0, and 4. So, I wrote it on in here. When x equals negative 1, 0, and 4. So here we go. 2 times negative 1 minus 1. So I plug in that negative 1 here. So I get negative 2 minus 1. So I get negative 3. Now I'm going to plug in a 0 equals 2 times 0 minus 1. So negative 1. Now I'm going to plug in a 4 equals 2 times 4 minus 1. 8 minus 1. So 7. So there's my 3 answers for number 7. Now for 8, wants us to evaluate for the same 3, for negative 1, for 0, and for 4. So for negative 1, I have negative 3 times negative 1, because that's my x value, is negative 1, plus 4. Negative 3 times negative 1 is 3, positive 3. So I get 7. If I do it again, I get negative 3 times x, which is 0 this time, plus 4. I get 0 plus 4. So I get 4. Oops, boop. Then I have negative 3 times 4 plus 4. So I get negative 12 plus 4. So I get negative 8. Negative 8. So there's my 3 answers for negative 1, 0, and 4. I get 7, 4, and 8. Find the value of x so that the function of x equals 1. So don't forget, f of x is the same as y. F of x equals y. So where does my y value equal 1? Well, it's right here. And that means my x value is 1. Right, because this point is at 1, 1, 1. It's at 1, 1. Where's my y value 1? That's where my x value is 1 for this one. Alright. F of x equals 2x plus 1. Find x so that f of x equals 7. F of x equals 7, so I plug f of x right here. So I have 7 equals 2x plus 1, and then I just solve for that. Subtract 1 from both sides, and I get 2x equals 6, divide by 2, and I get x equals 3. So x equals 3, where f of x or y equals 7. All right. Find the x and y intercepts of the graph of each linear equation. So don't forget to find the x and y intercepts. What I'm going to want to do is I'm going to want to turn y into 0 and then x into 0. So let's start with y equals 0. So I have 3x plus 2 times 0 equals 6. So that equals 0. So I have 3x equals 6. X equals 2. X equals 2. And now let's do the same thing where I turn my x into 0. So I have 3 times 0 plus 2y equals 6. So I have 2y equals 6. Y equals 3. All right. Moving on. 2x minus 6y equals negative 30. So I'm going to make my xy table. I have my y equals 0, my x equals 0. So let's do it. 2x minus 6 times 0 equals negative 30. So 2x, that equals 0, equals negative 30. Divided by 2, x equals negative 15. So my x value is negative 15. So I have negative 15, 0. Now I have, if I plug in 0 for x, I have 2 times 0 minus 6y equals negative 30. So that equals 0. So I have negative 6y equals negative 30. Divided by negative 6. So I have y equals 5. So there's my x coordinate is negative 15, 0, and my y coordinate is 0, 5. All right. Number 13, the points represented by the table lie on a line. Find the slope of the line. Now, please take note. Slope is the change in y over the change in x. Notice that the y is at the bottom here. So I'm going to do the y first because it's the change in y is on the top. So I have plus 3, plus 3, plus 3. So I have 3 on the top. Here I have plus 2, plus 2, plus 2. So my slope equals 3/2. If you got it backwards, it's wrong. A slope of 3/2 is much different than a slope of 2/3. Alright, now let's check 14. So we have our y over x. So our slope equals change of 0, 0. So I have 0 over plus 1, plus 1, plus 1. 0 over 1. What is 0 over anything? Well, we have a slope of 0. If you notice, our y value is 2. So this is actually a horizontal line, which has a slope of 0. But we already knew that because we had 0 over 1. Okay, moving on. Graph the linear equation. You could do this a couple ways. One way you could do it is you could get your zeros. You could find your x and y intercepts. Another way you could do it is you could turn this into the y equals mx plus b. So minus 2x minus 2x. So you have y equals negative 2x plus 4. Once I get y equals negative 2x plus 4, I know my slope is -2, and my y-intercept is 4. 1, 2, 3, 4. So I go up to 4. And then -2, I go down 2 and over 1, because -2 is the same as -2 over 1. Down 2 over 1. Down 2 over 1. So our slope looks something like that. Badoosh. Just like that. Alright, how about number 16? 16 is already written in slope-intercept form. So I know my slope is -1 over 2. My y-intercept is -1. So I go to my y-intercept of -1. And then I go -1, +2. -1, +2. Or I could go +1, -2. +1, -2. For negatives, I just have to make one of the numbers negative. And there's my line. Okie dokie. Last one, number 17. The function C equals 125 plus 0.5 m represents the cost, C, in dollars, of renting a car after driving m miles. A. Identify the independent and dependent variables. Well, we can remember, or if you remember, independent are the x values. And so what is the x value here? Right here is the miles. So the independent equals m, or miles, and the dependent, which is the y value, is c, or cost. So don't forget, independent is your x value, dependent is your y value. Okay, what would the cost be to rent the car and drive 200 miles? Well, the cost would be 125 plus 50 cents times 200 miles. So 125 plus 0.5 times 200 is 100. So you get 125 plus 100, you get $225. How many miles would a customer have to drive for the cost to be $339.50? Well, this is cost, so we plug this into the cost. $339.50 is our cost, and that equals $125 plus 50 cents a mile. So now I solve this equation. Subtract 125 from both sides. I'm left with 50. So $214.50 equals 0.5 m. Now I divide by 0.5. Divide by 0.5. 214.5 divided by 0.5 gives me 429 miles. So I'd have to drive 429 miles for my total cost to be $339.50. Alright, let me know if you have any questions. I'll answer your questions as best I can.